Hello and welcome to Cardiology 101. This is Dr. Shiraz, and today we are going to talk about a very important concept, that is how to identify STEMI in the presence of left bundle branch block. So the criteria through which we identify STEMI in the presence of LB3 is Sgarbossa criteria. And what is Sgarbossa criteria? It basically consists of 3 steps, and each step is given a number, and the number of more than 3 is significant. So for example, if we have a criteria that we get fulfilled and it gets 5 points, so it is significant and STEMI is present. Similarly, if we have a number that is below 3, then that won't be our STEMI. Alright, so for this criteria, you must be familiar with the concept that is concordance and disconcordance. What do I mean by concordance is the direction of ST segment should be the same as of QRS complex. For example, if I take this QRS complex, you will see that the QRS complex is positive, but the ST segment is going down. So this is disconcordant change. Alright, this is disconcordant STT changes. But in this ECG, I will say that the QRS and the STT segment are of the same direction, that is pointing upwards. So this is our concordant change. Alright. So the concordant ST segment elevation of more than 1 mm are significant. Alright, they will get 5 points. So what are those leads in left bundle branch block that have positive QRS complexes? Those are our left precordial leads V4, V5, V6, 1 and AVL. Alright. Similarly, if we have our ST segment depression, that is concordant ST segment depression, which is more than 1 millimeter in the leads that show the negative QRS complex, because when there is depression, our QRS complex should also be negative. So those leads which have negative QRS complexes, if they are showing more than 1 millimeter ST segment depression, that would be significant and it will get 3 points. Another point is ST segment elevation of more than. Third point is our disconcordant ST segment elevation of more than 5 mm. If it is more than 5 small blocks or 5 mm, it is significant and it will get 2 marks. But we know that for Sgarbossa to be significant, our number should be more than 3 or almost equal to 3. Here is how it looks on ECG paper. So for example, this is our positive QRS complex, and if our ST segment is more than 1 millimeter elevated, then it would be significant. And how much points it will get? It will get 5 points. Our next step was disconcordant elevation of more than 5 mm. So if we see, the QRS complexes are going down, but our ST segment has elevation of more than 5 millimeter. So it would be significant, but it would get only 2 points. Alright. Our third point was our concordant ST segment depression in the leads which have negative QRS complexes. For example, V1 to V3. If you haven't watched the lecture of LB3, you should definitely watch that, and it will make your concept of left bundle branch block more easier. I will put the link in the description. Another point that I want to talk about here is that I have made a WhatsApp group where we discuss ECGs on the daily basis, and we help each other develop better understanding of ECG. I will put the link in the description. You should join that channel and we will help each other in that group. Thank you. ST segment depression of more than 1 mm in the leads that are showing negative QRS complex. If it is that, then it will get 3 points. Alright. But a problem arises at this point is that although this criteria is very sensitive, but it is not specific. So we have another criteria that is called Smith Modified Sagarbossa criteria. It only adds 1 point, and that point is, even though we talked about elevation of more than 5 mm to be significant, but in some cases we need the ratio between the elevation of ST segment and the amplitude of the QRS complex highest wave. For example, in the positive leads, the highest amplitude will be of R wave, but in the negative lead it would be of S wave. Our ST segment elevation matters here. So for example, we have ST segment elevation and then we have our S wave. We will calculate the small blocks between the origin of S wave to the end of it. For example, if it is 10, alright, and our elevation of ST segment is almost 4 small blocks, we will calculate the ratio between these two. So what we will do is we will put 4 above and 10 below. If the ratio comes out to be more than 0.25, it would be significant. So in this example, the ratio comes out to be 0.4, which is more than 0.25, and it would be significant for our STEMI in the presence of left bundle branch block. So for example, if we have ST segment elevation that is 2 small blocks and our S wave is of 10 small blocks, so 2 divided by 10 is 0.2, which is less than 0.25. So our criteria would be insignificant and patient won't be having our anterior wall MI or STEMI. So let's look at the examples of ECG showing left bundle branch block and try to identify whether they have STEMI or not. First criteria was our concordant ST segment elevation in positive leads. What are our positive leads? V4 to V6. So if we look at here V4, we will see that in the standard left bundle branch block, in the positive leads, in the positive QRS complexes leads, our ST segment is depressed, but in this case this is elevated. So can we say that this is elevated more than 1 small block or 1 millimeter? Yes, it is. So our first criteria gives us 5 points, which is already significant. So this would be our STEMI in the presence of a left bundle branch block. Here is another example. So if I start from the first criteria, that was concordant ST segment elevation in positive leads. Can we see elevations here? No, we cannot see elevations here. All right. One, I cannot totally comment on the lead 1, but if we look at lead AVL, all right, we will see that there is almost 1 small block elevation in lead AVL. All right. If you look closely, if you look at this complex right here, the second complex, you will see that it is showing almost 1 small block elevation, which is significant, and it gives us 5 points, which is significant for STEMI. There are other points too that I'm going to discuss. There are 2 signs, that are Cabrera sign and Chapman sign. What is Cabrera sign? It is presence of slurring in the S wave. So which leads show us S wave in left bundle branch block? These are the right precordial leads, which are V1 to V3. Chapman signs is the reverse of that. And if we see the slurring in the R wave in our positive leads, for example V4 to V6, lead 1 and lead AVL, we will say that the Chapman sign is positive and patient is having STEMI. So if you look at this example, if you look here, there is slurring in the S wave. All right, there is slurring in the bottom right here, which are V3 and V2. All right, there is slurring here, and again we are seeing slurring in the V6 lead AVL. All right, so our both signs are positive here, so this would be significant for STEMI. So I hope this cleared your concept of Sgarbossa and modified Sgarbossa criteria, and now you will be able to identify STEMI in the presence of left bundle branch block. If you have any question, you should comment down below, and I will be happy to respond to them. And I will see you in the next lecture. Thank you.